So find the centroid of a T section as shown in figure. So now we have to find out the centroid of a T section. So here T section is a composite section because in this T section we have two rectangles. So first to divide the composite sections into number of elements. So here we are dividing this T section into two elements. So this is one rectangle, so we are giving number 1. This is one is first rectangle, and another element or another rectangle is, so here we are giving name number 2. So first step is you have to divide the composite section into number of elements. So here the T section is divided into two rectangular elements. So for this total composite section we have to find out centroid. So centroid means the point at which the total area is concentrated. So here T section, for weight of T section here we are neglecting. Centroid means it is related to area. If weight is considered, then we can call it that as center of gravity. But here whatever in the syllabus we are going to discuss all are plane areas. For these 2D plane areas we are going to consider only area. So the point at which the total area is concentrated, that is centroid. So to find centroid for these type of composite sections, in the previous class we have already seen one method. So according to that method we have to calculate centroidal distances from x-axis and y-axis. Here we have to remember one thing. So this T section is a symmetrical section, because if you draw a y-axis, so here we are drawing one axis, so this section is symmetrical about y-axis. So about this axis, whatever the portion you have on left side, the same portion you are going to get towards the right side. So left side of this section and right side of this section. So whatever the area you have on the left side of the section, the same area you are having the right side of the section. So this T section is a symmetrical section and it is symmetrical about y-axis. So here notice, if in a composite section, if section is symmetrical about any axis, either x-axis or y-axis, about an axis, x or y-axis, then the centroid lies on that axis. So here the centroid location will lie on that particular axis. So here in our example T section is symmetrical about y-axis. So that's why the centroid position or centroid is definitely present on this y-axis. So we don't know the exact location or exact position of the centroid on this y-axis, but centroid compulsory it will present on this axis. So it may present here, it may present here, it may be here or here, we don't know exactly, but the centroid location is definitely it should be on this y-axis. So this we have to remember for any symmetrical section. For example, if any section is symmetrical about x-axis, then the centroid compulsory lies on that x-axis. So in this case, here centroid lies on y-axis. So we know one condition that centroid lies on y-axis. So now what we have to do is we have to find out the position of the centroid on this y-axis. For that you have to calculate centroidal distances from x-axis. So from this x-axis, so here we are drawing x-axis. So this is x-axis and this is y-axis. So from this x-axis, at what point this centroid lies, that we have to calculate. That means we have to calculate centroidal distances from this x-axis. So that means we have to find out y bar. Generally centroid location is equal to x bar comma y bar. X bar means centroidal distance of composite section, centroidal distance of composite section from y-axis. So if this is x-axis and if this is y-axis, if any composite section is there, then here the x bar, so this is the centroidal position of an irregular composite section. So here x bar represents centroidal distance of composite section from y-axis. So if you calculate distance, if you measure the distance from y-axis, then we are going to represent with x, so x bar. And this position, if you measure from y-axis, then it is called y bar. So if you measure this centroidal distance from x-axis, then we are giving name y bar, because vertically we are measuring. So this vertical means respect to y-axis, so I mean in the direction of y-axis. So that's why we are giving name y bar. So here centroidal distance, so in the direction of x-axis, that's why here we are giving x bar, but we are measuring with respect to y-axis. From y-axis if you measure, then those values are x, and if you measure from with respect to x-axis, then it is y bar. So x bar, centroidal distance for composite section from y-axis. So in this figure, centroid lies on the symmetrical side. It is, this T section is symmetrical about y-axis, so centroid lies on y-axis. Here the centroid is lying on y-axis only. So that means this point is here only. Centroid is lying on y-axis only. It is lying on y-axis means, so what is the value of x bar? X bar is 0, because centroid is lying on y-axis only. So the distance measured from y-axis to centroid is 0 only, because the point lies on axis. The point lies on y-axis only. So here x bar is 0. X bar is 0 because centroid lies on y-axis because T section is symmetrical about y-axis. T section is symmetrical about y-axis. So it is symmetrical about y-axis, that's why point lies on the y-axis only. That means measured distance from y-axis will be equal to, that x bar will be equal to 0. So the next thing is we have to calculate y bar. Y bar means centroid distance measured from x-axis. So from x-axis you have to calculate. So in this case central distance is lying on axis only, y-axis only, but that means you have to calculate this y bar. So y bar, to calculate y bar we have formula sigma, that is ay by sigma I. That means a1 y1. Here we have two elements, a1 y1 plus a2 y2, a1 y1 plus a2 y2 by a1 plus a2. So a1 y1 plus a2 y2 by a1 plus a2. So here a1 area of first rectangular element, a2 means area of the second rectangular element, y1 means centroidal distance of first rectangle from x-axis, y2 means centroidal distance of second rectangle with respect to x-axis. So here areas will be equal to first rectangle area A1 equal to, so this rectangular portion, first rectangle. So here length is 80, width is 20. All dimensions are in mm. So 80 into 20, that is 1600 mm square. Area of first rectangular element. A2, area of second rectangle. So this second rectangle, length into width. So here 100 mm into 20 mm. 20 into 100, 2000 mm square. 2000 mm square. So we got A1 and A2. So now we have to calculate y1 and y2. So here y1 means centroidal distance of first rectangle with respect to x-axis. So now you have to consider only this first rectangle. So this is a rectangle. For rectangle the centroid lies at the center. So for first rectangle, this is the centroid for the first rectangle. So the centroid lies exactly at the center. So with respect to x-axis, from x-axis to center. So this is total, it is 80. So that means this is 40. Because centroid of this rectangle lies at center. For square, for circle, so for all these symmetrical shapes, the centroid lies at the center. So that's why here the total length is 80. So centroid lies exactly center. So if you calculate from x-axis with respect to x-axis, this value is 40. So this is y1. So centroidal, so here I am writing y1 equal to centroidal distance of first element, the rectangular element, central distance of element with respect to x-axis. So you have to measure from x-axis. So if you measure distance from x-axis, then we are giving let us y1, y2, y3 like this. So now we have to calculate y2. So centroidal distance of second element with respect to x-axis. That means from here you have to go with respect to x-axis. So you have to calculate from this x-axis. So if you observe the second rectangular element, so now you concentrate on this only second rectangular element. So it is a rectangle. So centroid of this second rectangular element lies at the center. This is a rectangle, so it lies at center. So here to here, this value is 20. So width is 20. That means here it is 10. So second rectangle, for second rectangle, the centroid of second rectangle. So we are considering only the second rectangle. For this second rectangle, centroid for this element, centroid lies at center. So that value is here. From here to here it is 10. So from here to here it is 50 because it lies at center. So it is 20, so it is 10. But we need centroidal distance of the second rectangular element with respect to x-axis. So we need y2. So y2 equal to centroidal distance of second rectangular element with respect to x-axis. So you have to measure from x-axis to centroid of second element. So we know here to here this value is 80 and the remaining is here to here it is 10. So total 90. So here y2 is 80 plus 10, total 90 mm. So here y2 is 90 mm, y1 is 40 mm. So now we got y1 and y2. So y bar will be equal to a1 y1, 1600 into 40 plus a2 y2, 2000 into 90 divided by a1 plus a2, 1600 plus 2000. So you may get some 67.78 mm. So y bar, here y bar means centroid of total section, centroid of total composite section, that is 67.78. So y bar means you have to measure from x-axis. So 67.78 means you may get around here. Here half is 40. So the centroid we got 67.78. 67.78 means you may get here. So this is y bar. So here y1 and y2 are centroidal distances of individual elements. y1 is centroidal distance of this first rectangular element, y2 is centroidal distance of second rectangular element. Y bar is here centroidal distance of this total T section. So centroidal distance of total section. Centroidal distance of total section is here we are got 67.78. So centroid lies on this y-axis. So here it is lying. So this value is y bar is 67.78 mm. So from here to here if you measure 67.78. So centroid x bar y bar will be equal to x bar is 0 because centroid lies on y axis. So the distance measured with respect to y axis means that is x bar will be equal to 0 because centroid lies on that axis only. Y bar is 67.78. So the distance measured with respect to x axis 67.78. So this is the location of the centroid. So whenever the problem has been given, then at that time first we have to observe that whether the given section is symmetrical section or not, that we have to check. If the section is symmetrical, then second step is you have to find out whether is it symmetrical about y axis or x axis. If it is symmetrical about y axis, then x bar will be equal to 0. If it is symmetrical about x bar, then y bar will be equal to 0. But at that time you have to calculate only x bar. So if any section is symmetrical, then you can calculate either x bar or y bar, that is sufficient. But if it is not symmetrical, then you have to calculate both x bar and y bar. So that's why whenever you symmetrical sections if you get, then calculating any one of that x bar and y bar, you can easily locate the centroid.